this is kind of fundamentally what a fabric looks like to us. So at the end of the day, you get node config at the bottom, right? This is actually going to be node-specific configuration. It could be an Arista device. It could be an SR Linux device. It could be an SROS device. Doesn't matter, but it's going to be device-specific. It is these apps' jobs, these abstractions, to figure out what that underlying configuration should be. And obviously, they can depend on each other. So a fabric is like a super, super composite abstraction. It just creates other abstractions, which create other abstractions, which eventually create node config. So this is actually what we're going to show in our first demonstration this morning. We are going to show us build a fabric. And we're going to count the number of clicks, because we talked a bunch about Kubernetes, and I get the feeling there's like some hesitation that maybe this is going to be too complex for people. I promise you it's not. So let's log in and get our first look at EDA. Yes?
Yeah, I wanted to just confirm that with you. So the more Kubernetes and primitives and atomicity, like there's a bunch of terms and things I don't know, and I start to kind of glaze over. It seems like that's not going to be a problem, right?
That will not be a problem at all, yeah. These are the things that are kind of like, why are platforms different? Very much in the weeds architecturally. What you probably care about is this, right? Is I just want to operate the thing. Show me how it works. So right now I've got a pretty small topology. I think I have 12 nodes in here. I've got two browsers up here because I'm going to keep coming back to this dashboard here on the right. You can see there's no leafs, there's no border leafs, there's basically nothing. This is an empty topology other than I've already onboarded the nodes. And we can actually go and look at our nodes here. And we can see this nice little topology view of our nodes. So we've got 8 leafs. You can kind of see that on the right. We've got 2 spines, and I actually have 2 border leafs too. So just to point out some stuff. Our border leafs are running SROS, so our kind of WAN operating system. Our leafs are running SR Linux. So I'm going to cheat and say this is a multi-vendor environment, okay? Just bear with me there.
It's not cheating. We'll allow it.
How did we get here? So we installed EDA on something.
Exactly.
We went out and discovered our network.
Exactly.
Yeah, okay.
So you have 2 options here. You can either say EDA will design the network for you. So in the same way you would see other controllers where you say, I have 8 racks, and I want dual homing in my racks, and I want a 4-to-1 contention ratio, and then we will make recommendations based on that. We'll build the topology for you. Or if you're opinionated on what the topology should be like, you can just define that topology and then onboard it with EDA. So both options work here. So all I've done is that latter option, actually. I've gone and like onboarded my stuff onto EDA manually. So that's our topology there. I'll call out a few more things. You'll notice that we have these labels here. So Kubernetes is very, very big on labeling things. We actually really like that idea, kind of the idea that you can decouple references between resources. This makes, like you can deploy a fabric and then redeploy the topology and nothing breaks, stuff like that. So having clean decoupling actually really helps. We are going to deploy a fabric, and all it's going to care about is these labels, essentially. So all of my leafs I've labeled with role equals leaf. My spines have role equals spine, and my border leafs have role border leaf, like you would expect to see. I have some other labels in there too. I have this redundancy group. You can probably imagine what that's going to be for. And we will use that later. So my odd switches are in redundancy group A, and my even switches are in redundancy group B. We'll recap that when it's time. So nothing's deployed here. I can actually go and look at one of our nodes configurations here just to prove that. So we have interfaces configured, but that's basically it. This is kind of what our factory config looks like in SR Linux. So I have a management interface. I have a management network instance. And that's about it. No services deployed, no underlay, no default network instance, nothing like that.
So that's configured, you said factory?
Exactly. That's our factory config on SR Linux, yep. So let's go deploy a fabric. Now, actually, we got to count clicks. I'm told I have to count clicks there. I'll even count clicking into fabrics. So that's 1, right? We're then going to create, which is 2. We're going to create the fabric. I'm going to come over here and copy this. And actually, I'll use this as an opportune time to talk about what a fabric is. So when we walk through some of that YAML stuff in the morning, you're going to see YAML stuff throughout the controller, but you can hide it if you like. You can just use the schema forms. I actually really like looking at it this way because it's laid out a bit nicer to read, especially because these are the only real fields you need to provide for a fabric. So with 25 lines of YAML, including all the metadata, we are going to build a fabric. So if I call out some of the things we see here, I mentioned we're going to use those labels. So our border leafs are selecting on this label here. We have leafs that will select on the leaf label, obviously. Spines doing the same. We also select the links as well. So that topology is more than just nodes. We actually model the links as well, of course, because you don't want to necessarily pull all the links into the fabric, but you want to pull some of them. So those are labeled as well. Now here, I'm telling it to deploy IPv4. So this is going to be an IPv4 fabric. And we're deploying eBGP in the underlay, and we're using the same eBGP for EVPN routes as well.
Did EDA generate this YAML?
Nope, someone wrote it.
Okay.
But you can build it using the UI. I mean, as you'll see in a second. So you can just fill out this form if you like, and it tells you which fields are required and which ones aren't. To save some time, I'm going to click in here. That's 3 clicks for those of you at home who are counting. And I'm just going to paste this. So based on that YAML, it's just gone and filled out with a bunch more default fields for me. Now I could add it to transaction. We're going to do that in a little bit, and it will cost me clicks. So I'm just going to commit it straight away. So we will commit that, and we'll see on the right that our dashboard will start to update. So now I have 7 leaves, 2 border leaves, and 2 spines. And eventually we'll see over on the right that our fabric is currently degraded, and we'll see our BGP peers will eventually start coming up, and we'll start to see routes exchanged. We don't actually necessarily need to wait for it, though.
Is that the transactions, like a config check thing before you push to prod?
Mm-hmm. Exactly. So yeah, everything, I mean, there's a bunch of stuff that happened under the hood there. We can actually jump in and see what happened.
Lots of events.
Lots of events, exactly. So I'll make this a little bigger, actually, so we can see it. So this is kind of the summary of that transaction. No errors, that's great. Zeros everywhere. But here in our CR summary, a CR is just a custom resource to us. That's what CR means. Don't get lost on the terminology. Just think of it as an object in the system. We changed 586 of them based on giving that one fabric. So if I look here, we can see there was 64 BGP peers that were created by giving the system that input. So we figure out, like our engine figures out all the dependencies between all of the different apps that need to run, and we compute that as a single atomic change. So we know the schemas of the devices we're talking to. They're Yang modeled, right? So we can actually verify using that schema off box before touching the network that, yes, this change is for sure going to work. And then once everything validates, we push it out. So all that happened underneath the hood in the time you saw that little saving gear go, and it actually ran and deployed the fabric, which I'm hoping in the meantime has gone up. And it has. So all my BGP peers are now up. Everything's looking good. I'm getting routes exchanged. Beautiful.
So there was pre-change analysis?
Yeah, there was a ton that happened in the background. We're going to see this as we dive into some of the other examples. I was really counting clicks there, so we will see some of the other stuff that happened. We can look at some of the stuff post-fact, though. So we actually have the ability to do diffs across that entire transaction. So a bunch of configuration was changed on the nodes, right? If I look at like one of my leafs here, we created all the underlay subinterfaces, and we actually allocated them IP addresses because there was a pool that was assigned in my fabric. We built our default network instance, which is our underlay network instance, right? It's the one that's going to do eBGP. We actually built all the BGP peers. We added policies. I mean, we built an underlay from scratch. And if you look at the border leaf, for those who are kind of SROS buffs, I'm not sure if there's any in the room or on the stream, this is an SROS config that was generated from that same abstraction, right? So this could be, in theory, any other vendor. You just need to have the underlying apps support them. So a bunch of config was changed there. I don't know how many lines, but I would estimate thousands and thousands of lines of config from just that one input to the system. You look like you have a question.
Well, where did the pool of IPs come from? Was that a separate step? Like how much of this was staged before?
Yeah, the pool I did create at the earlier. So we have kind of IP pools here that you can see. So there's the pools that I just created. So we handle the allocation of these as well. You see we're using an 11/8 there. The crazy thing with our pools is they're all deterministic. So it's kind of a big thing in EDA. Given the same set of inputs, you will always get the same output. It's kind of a fundamental thing. And you'll see why later when we get to the end of the demonstration. So anytime you run these apps, they'll always get the same allocation, unless you kind of delete them and recreate them. Now, again, that may not make sense. Yes, it'll make sense by the time we get to the end. So yeah, that was the only step I did, is I created the pools.
That's the real question behind my question, is you didn't spend 3 days doing prep for the demo that then makes it look super easy now.
I literally stood this up this morning, and I created those pools.
Awesome.
That was it.
And you have your own opinions on how to allocate addresses from a pool. Like you probably have some rules coded in.
We do, but even that is flexible.
Sure.
So if you have your own opinions on how you want the pools to be baked, so to speak, the platform lets you do that. You'll see that you have access to if I open up this segment here, you have access to reservations. So you can reserve based on a key, which is going to be requested by the app. So if you are very, very specifically, I want these specific /31s on all my ISLs, I want autonomous system numbers allocated a very, very certain way, you have that capability here as well, if you have those opinions.
So just to track the numbers, I put in one big CR.
It was 25 lines.
Right? That
Yes.
generated
Thousands and thousands and thousands.
the intermediate, the 568
Yep.
other CRs, and is every one of those 568 essentially a line of YAML modified?
Yeah, exactly.
Okay,
In fact,
and then that generated all the config changes so that those of us who like to edit configs can go see that there's actually configs on the devices. Okay.
Yeah, so this is kind of a big thing, right? We don't want to hide the underlying config from you. That is not the point of this system. In fact, you need that, and your operations teams are going to need that to understand how things are working. But we didn't want you to have to spend all your time dealing with that config, right? It's more of a debugging thing as opposed to a I have to interact with config. But yeah, you can see, like, this is the actual resource I created, the fabric. That's in the diff as well, obviously. And it created a bunch of ISLs, which are all in the diff as well. It created a bunch of BGP peers, BGP groups. I mean, created a ton of stuff. Each one of those in turn generates a little config snippet. They all get merged together. We do all the conflict checking, and then we finally transact with the network. Now, if it were to fail, because obviously this is not modeling things like TCAM, right? We're not trying to do that off box. We will do a network-wide rollback as well. So if we start rolling it out and, oh, that node rejected it for some reason that we couldn't forecast, we immediately roll back the entire change. So again, atomic changes. We are always in a golden state all of the time.
What are you using as a templating engine for your different operating systems and different vendors for this?
So we can look at that in a little bit. There's really no templating engine behind this. Okay. It's actually, what we realized is templating is very weak when you start needing to do things like allocations. So instead, it's all written in Python. In fact, I can quickly, I think I have an example up that I can show. Like this is the SR Linux banner app.
Okay.
So there's an abstraction for this too, which is the banner intent. All this does is basically figure out, is the device SRL? Is it SROS? Call the correct handler for me. And then this is all that handler does. It just calls this generate banner config, which is just a Python dictionary, basically, that models the JSON that we would send to the device. So this is the part, if you wanted to get under the hood, this is the part that's open source that you can start tweaking.
Because I guess the related question is, well, yeah, I've got other vendors there. What I guess, plugins, modules, what do you want to call it, exists today for those ones? And what about other ones that I might want to add now? Basically, how painful is that going to be?
I mean, I would hope that it's not. We built this platform to support that exact use case. So in Nokia, we plan on seeding most of the apps to start with, obviously, right? We need to build a bit of a community here. So we will onboard support for obviously our own operating systems. And we plan on doing Sonic early next year. And then we plan on doing one other, either Cisco or Arista are kind of what we're thinking. But we plan on supporting those. We're not expecting you. So the underlying primitives like an interface and a virtual network, which is just an overlay EVPN service, we are going to handle the multi-vendor for that, mainly because we think like we kind of want to seed the community. You could pick that up, of course, and say, well, you guys didn't do this for XYZ vendor. I'm going to add it, right?
So you've got this vendor, but I need this additional thing that you haven't.
Yep. It should be straightforward, exactly. I mean, that is like 36 lines of Python, including like a bunch of headers and stuff, that normalizes banners across operating systems, right? So this is not crazy stuff. Even if you're not like a Python whiz, there's nothing nuts there, right? That's what all the apps look like.
It's just raw Python code doing it rather than relying on Jinja. I was expecting you to say Jinja, but...
Exactly, because that's what everyone else uses.
Yes.
We didn't really think that you would be necessarily, again, automating just networks. Think of it being like a REST API or a compute or something else. So we felt that Jinja didn't give you enough flexibility.
Okay.
So Python gives you almost unlimited flexibility. You can do whatever you like. It does mean we need to give you tools in Python, and we obviously have our own little like SDK. You can see I'm importing stuff here to make that easy for you. So we understand that Python obviously is harder to write than Jinja 2 templates. So we need to give you the tools, and we've kind of built them into the product.
Okay. And
we leverage the same tools. So all of the automations you're going to see, this is a proper eat your own dog food kind of thing. They're all built on this framework. They're all open source, and you can interact with them.
How do you view the different OSs supported? Do you think of them as adapters? What do you
Yeah, so this is an interesting thing too. So how this would typically get solved, how other vendors have solved this, is they build a big monolithic normalized model, right? We actually have another product that we've done exactly this on. So the idea is that as long as someone writes the adaptation between the normalized model and the underlying vendor, then everyone else can just build the apps on top, right? It's a cool story. But what it does is it makes you, as a customer, beholden to me, as a vendor, to maintain that normalized model, right? Because it's hard-coded in the product, and you need to rev the core if you need to update it. We went an entirely different approach, where the apps themselves are standalone units of automation. They depend on nothing other than maybe they're actually creating resources of another app. That is the only dependency. Because a normalized model assumes you're managing a network, right? We'd have to model it like it might be OpenConfig or something. But it would be...
You have no model. You have no base model assumption.
There is no base model assumptions here. The apps are the ones that bring their own model, they do their own normalization, and they are iterable as a set. So yeah, it's very different to what you've typically seen. Yeah. I think it gives us, just a crazy amount of flexibility, as long as they're easy to write. So that was a big goal here, obviously, is we're going to make this super, super flexible, but it has to be easy to write. So we focused a lot on that. Okay, so going back to our demonstration here, unless there was more questions, I'm happy to answer more questions. So one thing you maybe noticed is there's only 7 leaves.
Yep.
But I had 8 in my topology, didn't I?
Did.
So let's go figure out what happened there. If I look at my topology here, I happen to know that it's leaf 8 that is not in here. It's missing a label, isn't it? It's not a leaf. And our fabric is selecting on leaves. So we need to update the label for this guy. So I'm going to go to my leaf 8 here, and I'm going to add that leaf label.
So shouldn't there have been some sort of warning that it did not pick up all the leaves? I mean, is there something proactively telling you that?
Well, what if your intent was to not pick up that leaf? How are we possibly to know? Maybe that was your desire. So, we could use the tools to understand what happened, but we assume nothing about the topology,
or maybe it's something
right?
that says unidentified, instead of just having the 722.
We could add. You could actually have we're going to get to how this dashboard is built in just in a little bit, but you could very easily add a tile there that says these nodes aren't in any fabric. Very, very easy to do. So yes, you could do that. And here I did it totally intentionally, right? I wanted to demonstrate what it would be like to actually extend the topology, what it would be like to add to it. Yes, Andy?
Could I ask Ida, why am I missing a leaf? You knew it was missing a label and put that in, but I wouldn't know that.
Yeah, in a theoretical sense, yes. I don't want to spoil what's coming after this, but
but that's
yes, yeah. that might be feasible.
Yeah.
So literally, you didn't express your intent regarding that leaf number 8.
Exactly. Yep.
Right, and you could call it human error.
You could call it a human error.
Mike
the system did exactly what
the plane is going to fall out of the sky at this point, right? But
yep. Yeah. So flexible system, right? We aren't even opinionated on what a fabric looks like. So the fabric could be anything. It doesn't even have to be a closed topology necessarily. So there's a lot of flexibility here, but obviously adding a tile that says these nodes aren't in any fabric, if that was a use case you cared about, would be, it would take you 2 minutes, right? And we'll show some of this later in the demo.
Yeah, following on those questions, how does Nokia see the enlistment of digital twin to
That's a fantastic question. So, if you remember, we have been big proponents for digital twins going way back, I think, when we did our NFD in 2021. We showed digital twins back then. What you're seeing here actually is it's all virtual. This is actually the twin I'm working on right here. So I don't want to spoil anything because we're gonna there's some big reveals coming later.
Okay.
But yeah, our philosophy here is that you shouldn't be making any changes to production unless they've gone through your digital twin first. And your digital twin looks like this, right? It looks like just another instance of your network, but where the nodes and the configuration are being driven by what's really present in production. Now you can imagine, going back to that whole GitOps thing that Wim was talking about, my digital twin is nothing more than a branch, right? So I can make a bunch of changes on my branch, I can test them over here. When I'm happy, I just need to send them over to production and say, merge in this. So yeah, that is fundamentally how this is all working. And right now I'm in the twin. So everything here is all virtualized. So I'm just going to add that to my transaction because you're not counting clicks anymore. So I'm adding leaf 1.8 to our fabric. Before I do this, I'm going to try a dry run. So this is getting into some of those checks that we're able to do. That was very quick. But what we did there is we actually ran this transaction like we were going to do it for real, but we stopped at the point where we would have pushed anything to the network. So, we ran all of our checks, we ran our schema checks, everything, our syntax checks all happened, and you can actually see what would have happened if I were to add that node. So just like we saw before, it's a standard diff. But this is a theoretical diff. This is actually, I didn't apply anything. So we can see that, yes, these 3 nodes got touched, obviously, because the leaf is attached to those 2 spines you see there. So those were the only nodes that got touched. But a bunch of other config was added. Our fabric had to update. It detected that that label changed. So this is kind of, again, going to that whole concept of being event-driven. So because the fabric is depending on topo nodes, it now creates like a bit of a hook and says, anytime a topo node is updated, get me to run again. And the fabric runs again, and because everything's deterministic, it either comes up with the exact same result it did last time, which is a no-op, or in this case, there's a change, right? There's a label on a node, so it's like, oh no, my output's different. This is kind of the magic of what our engine does. It'll figure out the delta. The app doesn't need to handle that complexity, right? It's just like, if you give me this input, here's what I would do. The engine has to figure out, well, you're doing that this time, but last time you did that, so I need to figure out the delta. I need to be declarative, right? So I need to transact this as kind of a clean set.
So do you have the ability through the GUI interface, the UI here, to actually select all of those leaves and put them in a group and then say apply this label with a variable?
Not through the UI yet. There's
4.
actually a feature coming at the end of the year to do exactly that. Yeah, to do kind of bulk edits for anything. Like it could be for labeling, it could be setting values. So it is coming. It's not here in the UI today, but yes, bulk edits are coming. Yep. Okay, so I didn't actually transact that, and we want to, so I'm gonna commit that. And we'll see that our leaf has now been added, and if I go look at my dashboard, yay, we got 8 leaves now. And my fabric's gonna be degraded, obviously, because I need BGP and everything to converge. So nice, simple change, adding a leaf to the fabric just by labeling it. Now, we're going to do something a little more creative. So I have my fabric here, and I deployed it using IPv4. And IPv4 is pretty old school. I think we all know that. So we're going to migrate this fabric to IPv6. And actually, I won't do like the hard, like kill IPv4, add IPv6. We can do that. That's actually usually how I demonstrate this. But I don't think that's realistic from a user standpoint. So all I need to do to add IPv6 to the fabric, and again, I could delete IPv4 here and I would migrate to IPv6. The system is declarative, right? It's going to figure out the sequence of steps that need to happen to actually enable IPv6 based on that new change. So I'm going to add that to my transaction again. And this is going from v4 to v6. And we'll dry run it again. So including all the allocations against the pools, everything just got dry ran there. We computed the full set, we validated it. The dry run worked, and we can go look at the diffs again. And sure enough, we have some new IPv6 stuff that's been added, including some IPv6 neighbors.
We're still on the digital twin.
We're totally on the twin here. Yep.
So the dry run lets me know I'm in the twin, and we're pre-validating.
Yep.
The commit would be pushed to iron or
well,
prod.
You don't even have to push it to iron, right? Like this is almost like a sandbox environment. Think of it that way. You can do whatever you like here. You can dry run stuff in this environment. You can commit stuff in this environment if you like. Eventually, you get the environment to the state you're happy with, and then you say, hey, production, here's your new state. And then production merges in that, and you're set from there.
Is it reasonable to call it a set of candidate configs?
That's the net, right? The net is a set of candidate configs, yeah. But we always want to store your input resources too, because we want to be able to, can't say it without spoiling things, so we'll find that out later.
What's your starting point to get to this level? Like, is it obviously rack, stack, and cable, but then, does an engineer need to first put on management IPs, or will the tool connect to serial ports, console ports, and start configuring right from there?
It uses full zero-touch provisioning, like you would expect, again, a controller being built in 2024.
Yeah.
So all you have to do is plug your switches in, cable the management port, and power them on, and you're basically done. What you will have to do in the controller is just tell us what the serial number is of the switch. That's it. We will be the ones to DHCP it, we'll bootstrap it, we'll make sure it's running the correct version, we'll push down the initial config. If there's any apps that are kind of like, oh, I already want to do stuff with that switch, I want to push config, they will get triggered to run, that all goes inside of a transaction. So yeah, super, super simple, right from power on to a fabric running. Okay, so we want to actually commit that. We want to kind of add IPv6 to our topology here. And just like that, we'll see that I just doubled the number of BGP peers probably. Sure enough, we now have 72. Sorry, 144. We'll let that converge. We actually don't need to wait for it. In the meantime, we talked a bunch about like configuration drift this morning, and the idea that a lot of controllers will prevent a human from coming in and changing things, right? The whole single source of truth problem. Now we understand in operations, there's always going to be cases where you want to make a quick and dirty change to either try and fix something or potentially to, you know, do what you're not supposed to do, which is just go and make changes on the node. It's not that we can block you from doing this, so we need to be able to handle it, right? So we have this concept called deviations. Again, this isn't necessarily specific to us. This term hopefully is well understood at this point. I'm just going to go and connect to one of my nodes here, and I'm just going to call as a deviation. So you'll see all of our sims are actually running inside of Kubernetes. So these are all of the nodes I'm talking to. Again, this is all running on my desktop upstairs. We're going to connect to leaf11 here, and we're going to make a change. Or later, we're going to come back to that. And you can see immediately on the controller on the left, we got this new row. There's a deviation on leaf11. So because we're subscribing to the configuration, you notice that was like almost instant, right? Like you're getting notified immediately as and when things happen. Right now, this deviation is not accepted. We can actually look and see kind of the intended value is nothing. The running value is for later. So there's a few things I can do here. I can reject it. We'll just do that for fun. And that's it. It's gone. So we just realigned the config here. Actually need to do a baseline update here. So now if I look at my interface, my for later is not there anymore, right? So we will add that back. And we'll pair again on the left. This time I'm going to accept it. Now, accepting a deviation doesn't really do that much. All it really does is say, I intend for this to be there. It's still a config snippet that's not really assigned to any application, but we're now persisting it, right? So it's part of the valid set of configurations for that device. It just didn't come from one of our applications. Now, there are some competitors that when they deal with deviations, it's a complete nightmare, right? Like the system starts losing functionality very, very quickly when you start introducing deviations. I'm not going to name names. If you know, you know. We really wanted to solve those problems, and actually some of the other problems that we saw with other implementations. Now, just remember there's a deviation sitting there. We're gonna come back to that later. So everything you see on the left here, in fact, I'll collapse it. All of these different categories, these are those apps I mentioned, right? So these were actually all onboarded through our app store. So you have some that deal with kind of overlay routing. There's not going to be too much in here right now. We have topology, obviously. And we have fabrics, which is what we've been using up until this point. So unfortunately, it doesn't look like the system actually supports overlays at the moment. And it's right now it's trying to be a data center controller. Overlays are quite important. So we're going to add that functionality to the system. So I'm going to go to our app store here. Now, something I did prepare earlier is I uninstalled our services app. And our services app, as you can see by the description, provides EVPN services for various network operating systems. So what I'll do, I'll bring my other window up here, pin this. What we're going to see, I just want you to watch down here, because again, even app installs are kind of events that come in, right? So we're going to see on the right, ideally, is some new applications are just going to appear in our controller here. So we're going to install here. Install our services app, and once that's complete, we'll see now we have our virtual networks guy down here. And it brings in a bunch of overlay services. Now, in theory, that could have been a new version of virtual network you could imagine, but we're kind of iterating at that kind of app boundary. So very, very easy to extend the system live while it's running, right? It could be a new version of SR Linux comes out, the schema changes, so we need all the apps to update. You can do that without touching the underlying controller, right? You just go into the app store, it'll say, hey, here's a bunch of app updates for you. You go update all, and you're kind of up to date from there. Now, the cool thing with the app installs is they are, as I said, part of that transaction, because installing a new app might fail, right? It might be that your underlying nodes don't support the correct version that it needs or stuff like that. It's always safe. Anything you're doing in the controller is always safe. It's always transacted. Did everything work? No, it didn't. Everything goes back. Or, obviously, it stays forward based on everything working together.
On this in particular, so SROS is the service router operating system, and services come built in. But you're telling me I need to install a services app. And I'm being a little energetic, purposefully.
Sure.
So what did you really do to when you you didn't instantiate all the functionality in the SR Linux and the SROS?
No.
It was already there.
It's already there.
So what did you do? What the heck?
I made our controller aware of that functionality via a new app. So I'm extending the controller here, not the underlying operating systems, right? So originally, the way I staged it, obviously this is not how a real deployment would look, is we didn't have that services app installed, which meant the controller didn't understand what a virtual network was, which is kind of our abstraction for an EVPN service. It had no idea. It wasn't aware of it. All I did was made the controller, here's this new app, and it brings all these new resources for you. So we have like VLANs and routers and bridge domains now. And now my controller supports these new resources, which at the end of the day, configure those underlying service things on SROS and SR Linux. So we extended the controller, not the underlying operating systems.
Hey, Bruce, real quick. I saw you in the terminal, which made me think of something earlier. Are we going to have network engineers making changes in individual boxes in the CLI as well as leveraging an automation platform?
I don't think so. I think you lose a bunch of the benefits of what the controller does for you.
I agree. I don't think they should, and I've seen that be a problem. Because some people are like, how can you maintain one state, right?
So that's what those deviations are.
So the recommendation is, this is how we're going to manage
for sure.
network.
Yeah. Right. I mean, you can't, as I say, the controller has to support that, right? Because engineers will do that. So you can't just be like, oh, you cannot do that.
But that's a nightmare.
It's not very maintainable long term. Especially, you can imagine there's a new version of the operating system, right? You upgrade your topology, and now that little config snippet that you added isn't valid for the new version of the operating system. It's on you now to manage the migration, right? The apps will do that all for you. So they will figure out, oh, you're running this version now? That means I need to give you slightly different configuration. So the apps kind of handle that complexity. They handle the lifecycle management for you. So our guidance would always be, don't configure things using CLI because you're losing a bunch of the benefits of the abstractions and the lifecycle of them and everything. But we cannot and should not prevent you from doing that if that is a model you want to work in.
I guess that's a thing they talk about. So the apps have got to handle different versions of the underlying operating system.
They do.
You've released version 56 or whatever, and you've reconfigured the way that EVPN stuff is defined.
Yep.
Maybe it's still the same, but change it around a bit.
Yep.
So within the app that I've installed here, I've got version 1.2 or whatever it is. Maybe I need to upgrade to 2.0 or whatever. To add support. Hopefully there's going to be some sort of thing there saying, hey, I know I work, I'm the virtual network, the services app, I work with these versions of blah. Hey, you're running this other version of blah, I don't know how to deal with that.
Yeah.
Or something to say, hey, hey,
so apps, they do declare this.
Like,
I can quickly show.
Tell me in a nice way that that's going to fail before you go and fail.
So if we look at our Fabric app, you'll see that they actually have to declare who they support and at what versions.
0.0.0, that's very helpful, yes.
Yeah, I mean, that's our internal build. We have to support that.
I was wondering about that before. I saw that on some others. I went to ask you, okay, that's good.
Yeah, so a 0.0 build is like an engineering build. That's what that is. And we are using engineering builds here. But yeah, so you declare it up front.
No, that's quite good having that in there, yeah. So I can see it in advance as well. Because the other thing is, of course, I would assume, let's say you're, 2025 and you release SR Linux 25 whatevers and change something around. I would hope that you would align your release cycles for the
It would be silly if we didn't, wouldn't it?
It would be pretty much par for the course with everybody to not have those aligned.
So we release...
Because it's always a classic thing, people release this and then the other sort of things are always lag a little bit.
Yeah.
But I would hope you would want to have those pretty closely aligned. But there's also, let's say I've got other vendors, right? I've got Arista stuff, and you don't know in advance that Arista is going to change their thing.
And we can't prevent them from doing it either.
Knows everybody, but
Yep.
But you don't know that exactly how it's going to change until they've published it. And so I go, cool, now I'm going to go and put this code, I'm going to run this thing because it's got some new feature that I really need.
Yep.
Now I've got to sit down and go, okay, do I wait for you to update the Arista thing?
Or do you do it yourself, maybe?
Myself, I don't want to do that. Well,
I mean, the other things you can do.
I would in this case, but
The other things you can do, if we're talking mostly around like abstractions and stuff like that, but we never prevent you from just configuring stuff. We don't recommend it, obviously, because you lose a bunch of the abstractions,
So I
but
can just go and drop on a.
you literally
a
can just
raw
like,
chunk of
here's a
config.
chunk of config I want you to add. We don't prevent you from doing that. We call it a configlet, what I'm showing here. So
Yeah, I mean,
you can do that too.
There's always reasons you end up doing some of those odd little things. I mean, it's you don't want to, but
Yeah, exactly.
or sometimes it's a case of, well, I've got this thing that works and I've got it defined as this configlet. And in theory, if I defined it all right in the service thing, then that would all work. But I haven't quite figured out how to do that yet.
Yep.
So this bit will just get that bit working while I can go on with my life and come back
Exactly.
and fix it
Yeah.
later.
Maybe you do it properly in Python at a later date. Yeah. So I mean, you'll see this theme throughout everything we do in EDA. We give you like this is the recommended way to do things. You get your best bang for buck if you use the abstractions, and everything's happy when you do that. But we never want to prevent you from using your network the way you want to use it, which is like, I just want to be able to configure things. If a controller can't configure things, we have a problem, right?
Like, I just want to use you as one thing to just push out my configs from some.
Which you can do. If that is the way you want to use this controller, using configlets, have at her.
Or, I mean, I see that more. Classically, that would be I have an existing fabric or existing network.
Yeah, this covers our
I
brownfield
need
story
to
quite
get
nicely.
Something coming in because I can't rebuild everything from scratch on day one. It's just not going to happen.
Yep, exactly.
Yeah.
Yeah, so you can either use configlets for that. We actually want to give you, I'm getting ahead of myself a little bit here, but workflows to help you do that too. Because what you really want is, okay, I have these abstractions, they generate config. I need to be able to basically reverse engineer that, right?
Tell me which bits would be covered by my
Exactly.
There's the service, the applications. Which bits are the odd bits out, and now
Yep.
help me extract that bit so I can. Yeah.
Exactly, that's what the workflow will do. Exactly that. Yeah, to support brownfield, because the reality is EDA is releasing like end of last month. Networks were built before the end of last month, so we have to support that.